Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. Today, we've got some interesting topics for you all. We have an update on the PHP compromise, Pwn2own 2021 results, and some various fun vulnerabilities. So let's jump into the PHP Git instance takeover update first. So, if you remember from the last time we covered this 2 weeks ago, I believe, the PHP developers announced there were commits pushed into their Git instance that they didn't author but came from their accounts. The PHP developers stated that they believed the Git server itself was compromised and not just a user account, which they elaborate on a little bit here, talking about how a commit was first made under Rasmus's name, then another one under Nikita's name. So it seems kind of unlikely that both accounts would have been compromised independently. So yeah, there is a little bit more information on that now. They ended up discovering that the attacker pushed the commits using HTTPS and password-based authentication, which the developer, they weren't aware that was possible to do, since they use SSH and key-based authentication, which is a lot stronger. So yeah, it seems somehow the attacker got the passwords to those Git accounts in order to make those commits. They think it was possible from compromising the master.php.net system, which is like their management system for tasks and authentication and all that stuff. They note that that's been running very old code on a very old OS and PHP version, and it used HTTP digest auth, which is basically like plain MD5. So they believe that's how it happened. They don't know for sure, though. It seems there's a little bit of uncertainty as to exactly how the attack occurred. But
yeah, it does seem a little bit odd. The main thing being that the attacker apparently needed to guess at the usernames, which then indicates that, if they had a compromise of the credentials, they wouldn't really need to do much guessing. They should just know what the usernames are. So that kind of tosses a wrench to the idea that was just the master.php.net compromise, like compromising that user database. That's the thing that actually makes it seem really weird to me, is the fact they apparently had credentials but not usernames, but then they were able to match the username to credentials. So it seems like there could have been some sort of exploit specifically in this type of authentication, perhaps. Or first they find the username and then they're able to bypass the authentication once they know a username, but not actually providing the password.
that is a fair call out, because that would kind of match up with what we were speculating on, with it potentially being a bug that somebody wanted to offload and they couldn't. Just based on the comments that were made in the malicious in quotes commits, because I don't think they did anything super serious, but it introduced attacker controlled text, and it mentions 0dm. So yeah, I mean, that would kind of match up with that idea. And yeah, that part of the story is a little bit strange to try to wrap your head around. So
yeah, it just doesn't make sense to me. I mean, I guess that's kind of the story they're going with, is perhaps that they're not holding hard on the fact that was what was compromised, just that's their running theory, which is fair.
Yeah, they just don't have all the information that they want.
Yeah,
which is gonna happen.
Yeah, well, especially if they're running an old system, I'm doubting that they were running a lot to collect information to actively be able to determine whether or not somebody, or to do the proper incident response, I guess I'd say.
Yeah. So what they've done is they've migrated the master PHP.net system to PHP 8. They now use bcrypt for passwords and reset passwords, obviously. And they move towards using parameterized queries to be more resilient against SQL injection attacks.
I mean, I'd be surprised. I'm surprised that they wouldn't have been doing that.
That is a bit worrying, yeah.
That's. I mean, I am disappointed that they are killing the Subversion support. Subversion has, a place in my heart. So the fact they're killing it looks like it wasn't. Yeah, well. Looks like it wasn't to use, so whatever. But yeah, they're taking some steps to resolve it. That's it. Some of these things really should have been done beforehand. Especially just running the old server. I mean, it doesn't take much to do your updates.
Yeah,
That said, we don't know how outdated it was.
yeah, so this was a nice like transparency report. But like we've kind of been hinting at here, this doesn't really reflect too well on PHP. Outright admitting using older code, older versions on the management system,
I mean,
and stating it was probably easy to compromise.
It reflects well in the sense they're being open about it. They're not trying to necessarily downplay. They're just sharing kind of what their guesses are at it.
Yeah.
And I can appreciate that. I'd rather see a company being open about it rather than trying to hide it. So I do appreciate the update regardless. And it sounds like they're at least taking some of the right steps.
Exactly. Basically, to sum up the story, it's like, yeah, some of the stuff said in here is a little bit concerning, but this level of openness and the steps that they've stated that they're going to be taking are generally in the right direction. So, a bit of concern, but also a bit of hope, I guess, coming out of that post. But yeah, still don't entirely know what the reasoning was behind the compromise, and it probably won't ever, honestly, unless the attackers outright come and say it or something. So yeah, we'll move on. Pwn2own happened last week, and there was a lot of cool stuff that came out of it this time around, thankfully. Those who've been watching for a while may remember I wasn't too thrilled about the last one, just because of the target selection. For those who don't remember what last Pwn2own was, I believe it was Pwn2own Tokyo in Toronto. It was the mobile, what's supposed to be the mobile Pwn2own, but there was a lot of IoT targets in there, and basically nobody went for the mobile devices. It was all routers and TVs and stuff, which was just not. It was a bit depressing, honestly. But this Pwn2own has a lot of cool targets in it, and hopefully some cool exploits that we'll see out of it. So I will quickly say one thing. There were a lot of people that were looking at Pwn2own and talking about it and asking when we'll see the issues come out of it. So Pwn2own is basically an event where researchers submit stuff and the vendors get it patched. We typically don't see vulnerabilities out of Pwn2own for months. Usually they come out in the form of blog posts like several months down the line from ZDI, a lot of which we cover on the podcast. But it's not something you're going to see like a week after the contest or something. It's quite a bit of time lag between when you see what was done in the competition from the outside. But yeah, like some of the targets that were hit were really cool. Again, this Pwn2own was virtual. It spanned across 4 days instead of the 2 that are more common, or 3, kind of taking advantage of that virtual aspect. Some of the targets owned included Safari, Chrome, and Edge. One of them worked on both Chrome and Edge, which was really cool. And funnily enough, I believe somebody dropped a POC for that bug today, from what I saw on Twitter. I'm not entirely certain if it's the same bug that was submitted to Pwn2own, but judging by the discussion, it seemed like it probably was. So, like I said, that usually it's several months before we see stuff out of Pwn2own, but there might have been a case of collision where you might be able to see one of those bugs already. And we'll probably cover that next week, because obviously I saw it like 15 minutes before we came on for the podcast, so I did not have time to look through it really. But yeah, I mean, there was also some MS Exchange server stuff from DevCore, virtualization stuff on Parallels and VirtualBox, and a few Ubuntu LPEs. Unfortunately, there were quite a few partial wins, 5 overall, which there was a bit of discussion around, as there often is, around whether or not it's fair to only accept partials. And the reason that a lot of those bugs were partials because the bug was, quote, already known to the vendor or ZDI. And there's a bit of discussion around that because from the researcher's point of view, there was no way they could have known that the vendors already knew about it if they haven't patched it yet. And then, like, that sucks, right? They put all this time into writing an exploit, all for the vendor to say, yeah, we knew about this issue, so no money for you.
So in fairness, I will also say, or at least to get ahead of one of the usual complaints is, the vendor could be lying. 1, ZDI has been doing this for quite a while. And 2, the vendor does have to show you in their internal bug tracker that they have the report for this bug, and they have a set amount of time to actually go and find the bug report for it. So it's unlikely that the vendor's going to be lying about it. It's a lot better than what you might see over at HackerOne, where less evidence needs to be provided. That said, I mean, this is also kind of the same deal as, you know, a normal bug bounty. Somebody has a duplicate report. They don't get paid on it at all. Or, well, it depends on the actual bounty program. Most bounty programs don't pay out on duplicates. This is basically no different than kind of your standard bounty program. And I agree that, like, it's a bit of a problem because obviously researchers are putting all this time into it, and then it sucks, like, you lose all that time because of it being a duplicate, and because they're holding off on the report until they actually use it at Pwn2own. Which means, like, if it's reported, you know, the day before Pwn2own, that sucks a little bit more yet, too.
That really sucks. That's very unlucky if that happens. That said, I can kind of tie that to a point somebody brought up from chat. Hexbone talking about the worst rule is the one that allows vendors to patch the application right before the competition. Yeah, that is really shady, and I don't really agree with it, but there definitely have been cases of vendors patching their products at the day before. And honestly, like, when you do something like that, that does seem like you're intentionally just trying to screw over the competitors to avoid trying to like get them paid out.
They're also making sure that any of the bugs they know about are not going to work.
Yeah.
I mean, I think that's fair on the vendor side, too. I mean, it sucks for the researcher side, and I think we really just need a solution to the whole, like, duplicate or already known vulnerability issue. I think that's where things need to come down to. I don't think we should be faulting the actual vendors for trying to patch their systems before it, or trying to make sure it's as secure as possible prior to it. If they are doing that, like, I don't think that should be a huge issue. That I don't think is a bad thing. I just think we need a solution on dealing with the duplicates and stuff.
So part of why vendors do that is, I don't really know why, but I know some vendors use Pwn2own as an actual, like, indicator of how well their security stance is doing. Like, did we get popped at Pwn2own this year? Like, that's kind of how they think about it. So if they can patch an issue before it gets exploited at Pwn2own, then that kind of, you know, makes them feel a bit better about it, I guess. I do kind of take issue with, like, patching the day before. I do agree that to an extent that kind of comes with the turf, right? With this kind of contest, you're gonna have to land on one side or the other, being the vendors or the researchers, and whatever side you choose is going to make the other one mad. And collision and whatnot is nature of doing exploits, but patching the day before has always kind of rubbed me the wrong way, honestly. But yeah, I mean, that said, I've seen that reason being cited for, like, potentially changing the way Pwn2own works, you know, which I don't know if I fully support. Like, one of the ways that I've seen being suggested for dealing with the issue is not requiring full chain exploits, right? So that way, even if you have collision, or if the vendor has already seen the bug, you're not wasting as much effort developing a full chain exploit, right? It's just the bug is burned. Oh well. I don't know if I really support that, because I do kind of like the way Pwn2own works with the exploit aspect. I don't think I'd want that taken away necessarily, because unfortunately it is kind of limited, the amount of avenues you have on the exploit dev angle compared to the vuln research angle. But yeah, I have seen that argument kind of brought up, that maybe ZDI should change some rules, or change the way that it operates a bit, because there were some unhappy people for sure.
I mean, you know what the thing is? You can report any bugs to ZDI without a proof of concept, without taking part in Pwn2own. I think having the full exploit is part of what makes Pwn2own interesting. It's part of what actually makes it a challenge. It's not just, oh, I've got this crash that's probably exploitable. It's actually exploiting it in a dynamic environment. And having even the updates happening just before it means your exploit needs to be able to withstand having an update, having some changes, or you need to be able to change it on the fly within a few minutes. I mean, that feels like part of the contest to me, not something that should be removed.
And it is why... Sorry, go ahead.
Yeah, I was just going to reiterate, if you want to just submit a proof of concept, you can do that directly to ZDI. I believe they'll offer a bit less, but you can do it.
So that's what I was going to get into. That is what you were saying with the exploitability aspect. That is partially why Pwn2own also pays so much more. Now, I think a little bit less is an understatement from what I've heard. The ZDI payouts are quite a bit less, yeah. Because like some of the browser bugs and stuff that were found in this competition were being paid like $50,000, whereas if you submitted them to ZDI, it's probably closer in the neighborhood of like under 10K, I would assume. From the limited information I know, it is a little bit hard to say because payout amounts and stuff are not disclosed for Pwn2own or ZDI submissions. Sorry, but yeah, like ZDI, you are getting quite a bit less. But like Z said, you have a lot less of a work burden put on you as well. So there's trade offs there. Yeah, in terms of results, first place this year, funnily enough, was a 3-way tie between DevCore, OV, and Computest, all at 20 points. DevCore actually met that 20 points with just one submission, an exchange server attack, with Jack Dates following at 14 points, and then Team Vietel, I think is how you say it, at 11.5 points. So yeah, it was more fierce in the competition this year than we saw from like the last event. And overall, just some of the targets hit were really cool. I will say the live stream, they had a live stream where they were doing like discussion in between attempts and live streaming the attempts. It was a bit disappointing for me personally, trying to see one of the attempts, and like I was looking at the Ubuntu LPE basically, and when I tuned into the stream and they switched over to the competitor, they were already on a root shell. Like they already ran their exploit. So it felt kind of weird to me, like, why stream that if you're just going to stream into a root shell? I do kind of get that they don't want information leaking about the exploit before it's fixed. But like you can control what you print on the screen when you run an exploit. So, and like
I wouldn't start putting the onus on the exploit devs though to make sure that their output is clean. I mean, especially because they may need to debug the exploit on the fly, right, as they're doing it. They're going to want that information getting printed, which is going to expose a lot of information, or probably expose information about how the exploit actually works.
Yeah, it's honestly just like a personal thing where I was like really disappointed. I was hoping to see the just something, like run the command, see a bit of ASCII art, and then a root shell. Whereas just going into a root shell was just a bit, I don't know, disappointing to me. But that's just a personal thing. I totally get why they do it that way. But yeah, like I was saying before that, I mean, this was just all around a really good event, I think, judging by like the targets that were hit and the results. So
yeah, definitely more interest than the last one we covered.
Yeah. Did fluoroacetate retire? I do not know. They did not participate in this competition as far as I could see. I don't know why exactly that is. I believe a lot of fluoroacetate's targets last time around were in the IoT stuff. So it's possible we'll see them again in the IoT if ZDI has an IoT-oriented event this year, which I think they probably will. But we'll see. But yeah, we'll move on to some drama, as we like to do sometimes. There's been some drama around Valve and their HackerOne program. Secret Club put out a tweet that they found multiple vulnerabilities in Source Engine, which is the basis for Valve games, including CSGO and TF2 and a variety of other games. One of the issues they talked about, they didn't really talk about the issue itself on Twitter, but they just kind of mentioned that they found one and a brief video of the POC running. But one of the bugs they found was reported 2 years ago and was an RCE that functioned just through the Steam invite functionality. And there were also 2 other RCEs which could be launched from community servers. And understand, these RCEs do have some significant impact, right? They can be used to run like spyware on a target PC, steal banking information or credit card info, as well as skins. For those who are familiar with the CSGO market, those do have quite a bit of monetary value. And these issues have been untouched for months or years by Valve. Like I said, one was 2 years that's been going unfixed, and the other two were for an unspecified number of months and for 5 months. So this Deserto post does a good summary on it. I do think it's a little bit over dramatic saying that you might have to stay away from the game. I don't think that's true necessarily, but I mostly just wanted to use this as a catalyst to ask, why does Valve even have a bounty program? I really don't understand.
I mean,
Because,
we've covered them paying out bounties before, so it's not like they don't pay out any bounties.
yeah, so, but this story is not the first time I've heard of where Valve has just left reports sitting in limbo for months on end. Like, absolutely, Valve has closed reports in the past and paid out. I'm not saying they're, like, not paying researchers, but
But they're not paying researchers in a timely manner.
well, not only that, they're not even triaging reports in a timely manner. So it's not only kind of screwing over the researchers who might want to talk about the research and get a payout, it's also screwing over the customers who could potentially get hit by these attacks because they're just leaving them for months. Um, and yeah, like it feels really like I sympathize with the researcher especially because it's not only about getting paid. Sometimes you want to share your research and you want to share your findings and do a blog post or a write up, and you just can't do that while it's stuck in limbo in the bounty program. Um, and yeah, like I don't know what it is with Valve when it comes to fixing bugs, whether they be these RCEs that we're talking about or some other bugs. Like there were some bugs that affected competitive integrity recently, like smoke bugs and the infamous coaching bugs that got a bunch of coaches banned by ESIC a few months ago. Um, it just seems like Valve doesn't really care that much. They only fix them when they have no other choice or when they're just bored or something. I don't know. Like there doesn't really seem to be any strong incentive to fix these issues on the Valve side. Like saying they're not proactive would be an understatement. They're not even really reactive to these reports. So, yeah, I mean, I don't really know what's going on with Valve, but I mean, if they're going to continue doing this, where they're just going to leave reports in limbo, just pull the bounty program. I feel like it's a waste of everyone's time and effort at this point. Like, I feel really bad for researchers who put months of their time into finding a vulnerability, exploiting it, and then it just sits there forever on a shelf. Like, it's just why, like, just don't run a bounty program if you're going to do that.
And their bounty program
Like,
comes through HackerOne, and this is one of those I've talked about it a little bit before, but I feel like HackerOne is in a position to actually move companies to have an increasingly more mature security program. And I've talked about before when it comes to disclosures, like at first allowing companies, to not disclose and then leading them along or even requiring them to start disclosing vulnerabilities. And this is kind of something too, where just the time to triage, especially if it's taking that long, it's getting passed from the HackerOne triagers to the Valve triagers to then kind of like verify. And that's probably where the issue's happening. I can't imagine HackerOne is actually taking 2 years to pass it over to Valve.
no way.
Like, I can't imagine that being the case. So this is also one of those cases where I think HackerOne could consider introducing like a requirement on how long it takes to triage certain things. I mean, obviously there can be exceptions, but setting kind of certain expectations of their clients also. I feel like HackerOne is in a great position to be able to push something like that forward. They're not going to do it. Like, that's not good for business to push a business beyond what they want to do. So I get they won't do that. But they're in such a good position to improve the security of a lot of things, of a lot of companies, that I kind of wish they would start using that.
Yeah, I agree. I think that would be a good move on their part. And yeah, I mean, that's kind of the only reason that Valve does what they do, right? Is they can get away with it. They can get away with running a program without any like level of expectations on the vendor side. So yeah, that's a good suggestion. I like it.
And I will say one other thing, kind of in fairness here, is we don't have details about how this exploit works or why they might not have paid it out or decided not to, or why they may not have triaged it. Like, I mean, so not triaging it actually, like, I can't think of a plausible reason for that not to have occurred. Like, triaging is should have happened. Like if they just didn't pay it out, that's a little bit different. But at the same time, without details, like we don't know what the complexity could be, and we can't even really speculate on that.
Yeah, I mean, if they received a report and then they decided, okay, the circumstances of this, like, yeah, it's an issue, but it can't really be used, and we're not going to bother paying for it, like, and then they close it, that would be different, right? Because then, okay, it's closed, you don't get a payout, which might suck, but then if Valve doesn't really consider it much of an issue, then you can talk about it and you can release your research if you want to. Whereas if they just leave it sitting untriaged, you just it's like you never even really discovered it because you can't
you
talk
end up
about
in
it
that
either.
limbo, yeah.
Yeah. And that's another point, yeah, from chat. Hexpone says their big payouts are a siren call. And yeah, like that's what attracts a lot of people to the Valve HackerOne is, for one, it's binary, which you don't always get to see on HackerOne bounty. A lot of them are web. And the payouts are big. Like you're talking about like a 10K payout for an RCE and Source Engine from their payout table. So yeah, it's a nice payout and it's like a cool target to look at, but it's just ruined by how badly the bounty program is ran by Valve. So yeah, it's just a really unfortunate situation all around, I think. But yeah, we can move on to our exploit section of the show. So YouTube exploits are back from David Hugh. We've covered being able to get snapshots of private videos from users and being able to get into a user's private special playlists, like their uploads and likes and whatnot, which were the past two issues. Both of them required some special circumstances to exploit, though, namely needing the video or playlist IDs. This one, though, is a much more practical attack. And this is a new set of issues because it basically just involves getting a victim to visit a malicious link, effectively due to a CSRF issue. So with YouTube, you can use it on smart TVs and whatnot. And YouTube has an API in order to provide remote control to play it on a TV or do whatever else. And that's called the Lounge API. The way they detect your TV is pretty simple. It's just like a simple user agent string check, since the YouTube TV apps use Cobalt, which is like a lightweight browser for those types of applications. The main problem is that the Lounge endpoint doesn't have any CSRF protection, so an attacker can send a request to that endpoint on a user's behalf from a malicious website to get a Lounge token, which can then be paired with an attacker's device. And that can lead to compromise of both unlisted and private videos that a user has in playlists. Unlisted videos, the attacker can get the IDs, and they can just steal those to view the video, since the ID is effectively like the password for the video. And private videos can be played as well, according to the blog post. I'm not entirely sure how that works, since that should be bound to the account still.
So the way that worked is with the Lounge API, when you actually have a graph on here, I think, kind of showing, yeah. So the user would send a request like, play this video to the Lounge API. They'd include that Lounge token that you mentioned, or that Lounge ID. They'd include that with it, and then the TV itself is doing long polling against that Lounge API, and it's looking for, are there any new commands for me? And it's like, yeah, okay, play this video. And so the user, when they asked to play that video, I'm not sure if the user was also including it or if the Lounge API created the token, but there was a CTT token. So when the TV goes to play a video, it'll go and get the video information. It's like an endpoint / get video information. And they'll include the video ID and this token that it received from the Lounge API that is specific to the video. So that is the kind of authentication or authorization token that needs to be passed through. Without that, so without the legitimate user who is allowed to access the video providing that CTT token and then passing it over to the TV, you wouldn't just be able to play the video. So that's where the CSRF comes in. You have, you're able to make requests that are authenticated as this user to the Lounge API. And it'll be authenticated using their cookies, like I said, CSRF. So when they say play that video, it'll work. And then to get more videos, we've talked before about not really an issue, but the predictability of some of your playlists, those kind of built-in playlists like your liked videos, and specifically your upload playlist. Instead of doing play a video, you could also do like play a playlist. So you combining that, you can kind of predict what the playlist ID is going to be for the uploads, and that's how you can kind of leak all of the private videos without actually knowing any of the private video IDs by predicting what their playlist will be.
Yeah, and that was on the last issue we covered. I wish I had the episode number on hand. I should have went and got that, but I forgot to. But we did talk about the ID structuring and how that all works. David Hugh has a previous blog post on that. If you want to see more around that that particular issue. But yeah, this blog post goes pretty long into the story of how this was discovered and the thought process behind it. Talking about how he thought about it after playing a private video at a friend's place on their TV app without the TV being signed into their account. And talks about how they built like their own TV application that makes the necessary API requests to pull off the attack, spoofing a TV basically. So yeah, like awesome attack.
Yeah,
Researcher ended up getting
attack. I do want to pull one question out of chat from FreeSRX. What can a malicious party do with knowing a user's private videos and playlists? The main thing there is you can imagine like certain brands will use it and they'll have some private videos. Or perhaps you know somebody that just uploads some private videos for themselves and you target them that way. So this is going to be a targeted attack, so you do need to predict that playlist. So you can't just like generically run it against anybody. But basically, you're just getting a leak of all of their private videos. Well, all of their videos, but that includes the private videos and unlisted. So my thing would be, business intelligence. I could imagine it being used in that sort of case if you're able to get somebody who manages a brand. XH or EHLE also mentions bug bounty proof of concept videos would be another example. There are definitely some sensitive videos that get uploaded. You'd have to be targeting them specifically, but there definitely are things you can kind of pull out of that, or pull out with this.
For sure. Yeah, so researcher ended up getting a $6,000 bounty for it. And it's cool because it has a similar impact to some of the previous attacks in terms of what can be accomplished. And actually, it's even more impactful because the previous attack on private videos, they just managed to get snapshots, not the actual video playback. You didn't get
didn't get audio
smooth stream, and you didn't get the audio. Yeah.
That said, I do love that. Using the thumbnails to rip the video, I do like that attack. Like I thought that was a
really
cool way to go about it, grabbing the thumbnails. I don't remember what episode we talked about it on, but basically he grabbed the thumbnails using, it was one of like the advertiser APIs or something, where you can add a video and tell the thumbnail or something. It was a separate application that just interacted with YouTube, so it didn't have the same privilege checking.
Yeah.
I thought it was a really cool attack, and this one is, well, I guess it's not really in the same vein, but yeah, I've liked all of this guy's posts. They've all been some interesting YouTube bugs.
Yeah, cool bugs and well-written posts. And yeah, this one's like the most practical one that we've covered so far, I think. So it's a good addition. Up next, we have an interesting issue in a sensitive website, let's say. It's a port site, which makes the issue all the more problematic because the issue is basically an endpoint that apparently allowed you to steal all account information, such as email and password, and the passwords were only protected with MD5. We don't really have many of the specifics. It is a limited disclosure, but if there was one type of website you wouldn't want your email, especially, and your password leaked from, I think that would be this kind of site. The issue itself is a little bit old. It's from March of 2019, but it was just disclosed April 6th. They ended up getting a $5,000 bounty for it. I will say I am not totally sure how you accidentally expose an endpoint that discloses account passwords. That must have been a debugging-based endpoint or something. That is really strange.
Well, another option is if you set yourself up an endpoint that is just like user information and it just dumps all the, imagine a profile endpoint makes like a JSON or gets a JSON response or something, and in that response it basically just dumps whatever it has in the like users row in the database or something. That could then include the MD5 password along with email and everything else, and then the UI will decide what to display. I'm not saying you should implement a profile that way, but I have absolutely seen things like that being done.
Yeah. The other thing that you mentioned was MD5.
Yes.
MD5 in 2021.
MD5 in 2021 is without reason. We did actually just talk about the PHP thing where that was using Apache Digest. Well, I guess just technically HTTP basic digest, whatever. Where that also kind of had MD5 a little bit, or base64 if they're doing basic. Little bit more complicated at least than just the hash of the password, whereas in this case it seems like they literally just hashed it with MD5. There's no mention of a salt here either, which is even worse.
Yeah, I mean, if they really wanted to protect passwords, they should have just hashed it with CRC32. I mean, that was a joke. Just to be clear.
CRC32 is, very strong.
Very, very strong. But
I mean, on a more serious note, though, if you are doing passwords, I often hear people, this is kind of a side topic, but even some security people, or at least beginners, they're saying like, oh, just, hash and salt. And these days, no, you need to do more than just hashing and salting. I won't go into the details here, but basically defer to somebody else or defer to a library that specializes in dealing with the passwords. Like, you shouldn't be calling the hash functions yourself. Ideally.
If you're using something like PHP, it has
password hash.
Pretty solid password hash. Yeah, it has a solid API for doing that as well. So yeah, just use better channels. It seems like this site wasn't designed in a very smart way. Although I don't know how old it is.
I was just surprised to see MD5 in this year.
Yeah, you were in like that "what year is it" meme. So we also have a post about instant payment notifications, or IPNs, and issues between the vendor checkout page and the payment processor, being a UK-based one called Skrill, and its use on 2 gambling websites. So they go into a bit of background about how the authentication flow, or how the flow works between the vendor checkout and the payment processor, and what happens in between those stages. Talking about how Skrill will generate an MD5 signature as an authenticator for a transaction, and then that MD5 signature is generated using several bits of information, including the merchant ID, transaction ID, and all the information that's attached to the transaction, as well as an MD5 hash of the developer's secret. By the way, I don't know what it is with MD5 today. It seems to be one of those show themes. One issue is around the developer secret, being that the plain text that gets hashed can only consist of lowercase alphanumeric characters with no special characters allowed, and it's limited to 10 characters long. It's like the opposite of what you want for passwords.
Yep, my secret word, 10 characters. Sounds good. I mean, appending too many characters, so like the 10 characters is it's not good, but it's not as bad as the fact they all have to be lowercase and no special characters. I think including uppercase, including special characters, 10 characters, like, it's not great, but it's not terrible. But anyway, because of that, you can probably guess where this is going, that if you're able to leak some of this other information, such as the merchant ID, the transaction ID that it comes up with, if you're able to leak that information, which they talk about doing by modifying the status URL, so basically the URL that's used as a callback, which isn't always going to be the case. It depends on how they're actually set up. But in the case of a couple of these casinos, they were able to control that status URL, which then allowed them to kind of leak some of this information so they can then go ahead and try and brute force and figure out what the MD5 signature actually was. And then, as you can kind of guess, they could spoof that reply and make it seem like, because obviously they're not checking if the IP is correct or it's coming from the proper domain, just, hey, we got this endpoint, it has the right MD5 signature. Hey, they must have sent us $25,000. Totally legit. It basically just leads into spoofing, which, I mean, definitely a fun attack. His bounty, unfortunately, was not the full 25,000 that he pretended to send in, but instead $10,000 for it, which is still fair. Definitely a very damaging issue.
Yeah. Basically, the main problem there, though, is the entropy, right? Your entropy is far too low with those restrictions on the password. He ended up reporting the issue to the gambling companies and advised them to generate the transaction internally and validate the transaction details from the Skrill servers before processing them. He also states they should use better passwords, in quotes, though I will be honest, this point kind of confused me. I don't really understand what he means there, because the password issue, from what I understand, is an issue on Skrill's side, not the gambling websites. It's Skrill that imposes those restrictions.
Well, we don't know what password he actually came across. Perhaps they did have a fairly weak password even with that 10 limit. Like, maybe the password was like their name or something. But we don't know that. That said, yeah, I do think that is more a Skrill issue, that they should allow more than just 10 lowercase characters.
Yeah, that's one of those things where it's just makes sense to strengthen your security on all the angles you can, and basically force your clients to use secure secrets. So, yeah, cool attack though, and it kind of played on multiple issues, right? That issue of low entropy, and also not internally handling the callback stuff. All right, so our next vuln is a zero-click in the Apple Mail application on macOS. It's related to compression, and more specifically automated decompression of attachments that are sent from other mail users. So when you send email on this mail application, attachments can get compressed, right? And then it can put in the MIME headers to let other Mac OS mail clients know that, hey, these attachments are compressed. So when you receive the email, just decompress them so that they're readily accessible for the other user. And it uses zip for compression. The problem is relatively straightforward. Bits of uncompressed data are not cleaned from the temporary working directory, which is also not unique between systems. So an attacker can basically establish symbolic links in the temporary link to other files with a malicious compressed attachment, and then send another attachment which will utilize that symbolic link to do something damaging, like get an arbitrary file write, for example. Now, you are restricted to the mail temporary directory, but there's still some interesting things in there, such as the mail rules list is one that they hammer on in this blog post. The author points out you could add an auto forward rule to leak email data, or it could be used to leverage another bug potentially to chain with for a better compromise, though that is theoretical. They just kind of touch on that as like a quick throwaway point. They don't have an example of an attack surface you could potentially take advantage of, but that possibility is there. So yeah, not a super complex issue. It's mainly just the fact that the files that are decompressed are not cleaned up between runs, or between instances, I guess. Timeline was fairly reasonable. The issue was reported May 16th, 2020. Apple shipped a hotfix on Catalina Beta 4, I believe, on June 4th, and then to supported stable versions July 15th. So within a month or two. But yeah,
Yeah, I mean,
I will say this is a bit weird. I would expect the temporary files to get cleaned up, but I don't know if it's like a logic bug where maybe some of them got cleaned up, but certain types of files didn't. But
well, it
yeah,
might
there wasn't too much
also
elaboration on that.
kind of be a situation where it cleans up, but only once it's done processing the entire message or all the attachments or something like that, rather than doing it with every single attachment, because this sort of, in theory, like under normal circumstances, you wouldn't be overwriting files because you wouldn't have two attachments of the same name. It's just because it does the auto extraction that you kind of run into this.
Yeah.
But I mean, it's one of those classic issues just with zips and also having the symlinks inside of a zip or inside of the compressed container.
Yeah, honestly, they should just probably be validating the zip attachments and just not extracting symbolic links and stuff. But yeah, I mean, it's always fun to see Apple stuff. But yeah, not too much to say on that one. It was a pretty straightforward issue. We have a quick stored XSS in the privacy-based search engine DuckDuckGo in its search result page. The XSS is in the green URL text underneath the headline of the search result. That URL was not sanitized against cross-site scripting, which could be taken advantage of in a number of ways using a few websites. Ways they point out is using search queries on things like Urban Dictionary and Bitdefender profile URLs. So yeah, you could just generate a query for that with an XSS payload in it and send a link to the search results page for that and XSS somebody. That said, this would be a pretty obvious attack to anyone who scrutinizes links before they click them. You'd be able to see the XSS payload directly in the URL, unless it was chained with another issue, like one of those issues you see sometimes with chat clients, where you can substitute the link that you're directed to from what's actually being displayed to the user, which is an issue in and of itself. But
yeah, so you don't. Well, they use the example here of like having the actual XSS payload as part of the search in this case. In theory, you wouldn't have to do that. It would be more difficult to go about it, but you could come up with some page that has that URL but has a normal looking thing, because the search doesn't need to be a popular search. It doesn't need to be something that they're even going to naturally look up themselves. It could just be like, a face smash on the keyboard, and you register that domain, so it's going to come up when they search for it, and you get that URL in there at that point. Then it's not going to be in the URL when they click it, and it will execute when they load. So like, you can hide it as long as your search query pulls it up. That's kind of the main thing. Just their example here has it being right in the URL. But in theory, as long as it's in the URL, it does need to be in the search string.
yeah, and Rudimel from chat mentions a link shortener. That's another valid point to bring up to try to obfuscate that you're XSSing.
I'll be honest, I'm more likely to scrutinize any short links that I run across than I am just random links.
See, where that kind of falls apart for me is on Twitter, because unfortunately Twitter uses short links for everything. So there are some places where I could see it being pulled off, and I think, yeah, you mentioned T.co right in chat, so yeah, I mean, there are a few avenues I could see a link shortener being taken advantage of, but yeah, I mean, you'd have to get creative, basically, to be able to pull off this attack in a practical context. So I find it very interesting that there was even this issue at all, though, in DuckDuckGo's page. That seems like a fairly obvious thing to check for XSS as that kind of data, but I don't know, maybe not.
It feels like, I mean, maybe this kind of has some legacy code to it. I don't really know much or anything about DuckDuckGo's code base. I don't know. It feels like one of those things that, like, in most web, well, not most, but in a lot of web applications these days that are actively maintained, they're also using a framework that should be dealing with most of the simple XSS cases. Assigning the text to be displayed somewhere, not just using it as HTML.
Yeah.
So that just feels a little bit odd to me.
Yeah, I guess it was just something that slipped through the cracks somehow. I don't know. But yeah, it was interesting to see that it was there nonetheless.
Yeah, like, I can kind of understand why somebody might why somebody might look this and think, okay, the URL is somewhat safe. Not really thinking about actually including including these characters, especially if you're maybe expecting it to be URL encoded or something. Like, they might be thinking along that. Like, I could understand the thought process there.
Yeah. All right, so another GitHub issue. This one is affecting private pages and is potentially the highest paid bug bounty by GitHub so far. I did try to take a quick look at that. It was hard to confirm because they have a lot of reports, by the way. But yeah, it consists of a few different issues that are related to one vector. So the post starts out by detailing the authentication flow of how private pages are accessed on GitHub, where a user is checked if they're authenticated. If not, it'll generate a nonce inside of your session and direct you to the login endpoint with the page ID, where after a successful login, it'll generate an auth token and associate it with that nonce. They also state that the session cookie where the nonce is stored uses the __ host prefix, which most browsers, except for IE, will respect and prevent JavaScript from setting it against a non-host domain. The page ID in the session cookie is where the first bug comes into play. They found an issue where you could inject the page ID parameter into the cookie, which was interesting but quite restrictive because the ID is converted to an integer, so they couldn't easily use any non-integer characters, including spaces. What you could potentially do, though, is inject a null byte to break out of the integer parsing to do something interesting there.
Well, so you could inject the spaces. Sorry, I might have just misheard you. It sounded like you might have said that they couldn't inject spaces, but that was the thing that actually triggered them to the fact that there was a bug going on here. There was some sort of disconnect going on. Because what ended up happening is they had the page ID. If you're able to see the screen and not just listening to us, you'll notice there's a space before that semicolon. They were able to get that space in there because it would parse it to an integer, but when reflecting it in the cookie, it would use the original value. So they have this pseudocode here where it would do the 2 integer on the page ID, but then setting the cookie, it would use the original value. Yeah, so there's kind of that disconnect between the parser and that. So then what you were just about to get into is the fact that, yeah, and then the way they got around not being able to include any sort of text characters because the 2int would fail then was by using a null byte to kind of stop the processing, and then after the null byte, they can include whatever characters they want. But whitespace was kind of allowed, and the thing that kind of had them notice that there was a possible bug there.
Yeah, sorry, I think I confused myself there. For some reason, I thought they were saying that whitespace wasn't allowed, but yeah, when you explained it and when I was reading it while you were talking about it, yeah, that makes more sense. I don't know how I messed that up, but thank you for correcting me on that. So yeah, by injecting a null byte into the content body, they were able to use that in order to get XSS on the page. They did have to put it in the content body. If they put it in the header would get rejected.
Yeah, and just kind of for clarification, say getting into the content body. So the traditional way to get access when you have a header injection like this, well, technically it's not a header injection, as Spectre just said. Couldn't have a null byte in the header, but you could have the white space. So character return new line, character return new line. Basically, having a blank line is how HTML separates the headers from the actual body. So you inject the 2 new lines, null byte, and then you control the body. I mean, I assume a lot of you probably already knew that, but I figured I'd explain it at least.
Yeah. So that gave them JavaScript execution on the page. The third issue was required for getting around the nonce checking in the authentication flow. And that was based on the fact that sibling private pages within the same organization could set cookies on each other, which kind of makes sense. But they note you could take advantage of that by setting a fake nonce on a sibling page, then getting it passed down to the private page. And that's if you can bypass that host prefix protection, which leads to issue number 3, which is where the browsers were case sensitive to the host prefix check, but the GitHub private pages server was case insensitive. So again, you kind of have that desync going on. So if you change the cookie name so the prefix was a different case, GitHub would still accept it even if the browser wouldn't. The fourth issue that makes this attack really cool is the fact that the response on the auth endpoint was cached based on the parsed page ID value, which means that an attacker can basically do cache poisoning to hit other users with the XSS, making it a much more interesting attack. Final issue was a misconfiguration where public repositories could have private pages, which could be viewed by anyone. So I just did private in air quotes.
Yeah, well, it's still kind of intended, like it's a private page or it's part of the private page program, but if they make the repository public, then anybody can read. So I don't know. I mean, that feels almost intentional. Like, yeah, you make it public, of course people can read the pages now. Like, I don't know if I'd necessarily agree with calling it a misconfiguration. I know they do in the write-up, so fair enough, whatever.
Well, I think where the misconfiguration comes into play is, okay, yeah, you can view those private pages, which is intended. but it allows a pivot point to be able to get access into internal private pages by cache poisoning an employee. Because remember, sibling cookies can set cookies on other pages in the same organization. So that's where I think it kind of comes into play with the misconfiguration is not handling that case, I guess. It's kind of an edge case that escapes.
You can do that. I believe you can do that with the original one, though. So, say I have the example here. Now, when a privileged user visits the unprivileged organization, they get the XSS there, and they set the domain cookie there, and then perform the same attack against a privileged organization. Whereas using this thing, using the public-private pages, if something had that set up, then they'd be able to attack it directly without that middle step. Because they were going after that last one for the CTF bonus, which I guess we haven't really mentioned yet, but with GitHub's bounty program, specifically on the private pages bounty, they have bonuses for actually writing payloads that do something. So they've got flag.privateorg.github.io. If you're able to read that with user interaction, I think it's like a 5k bonus. If you're able to read that without user interaction, it's 10k. And then if you're able to read it without user interaction, just if the account is outside of the private organization, they get another 5k for it. So it's going for the bonus is where they kind of added in this, is where this part came in. So I think that it basically just lets you skip that one step of the exploit chain.
Yeah, those CTF bonuses were really cool, I thought. I don't remember hearing about that when we've covered like some of the other GitHub issues. Maybe we did, and I just
covered it once before, not this one in particular, but when we were dealing with the auth bypasses, I think in GitHub, the CTF bonuses at least came up in those write-ups, I think.
Oh, okay. So I just probably forgot, but yeah, that was an interesting aspect. But yeah, I mean, not a bad payout for these issues. Like I think you mentioned the payout amount, but yeah, it was like 35k total. So yeah, quite a nice haul for the researcher.
Yeah.
Next we have a cloud attack, a privilege escalation inside of Azure Functions containers, which run Docker in a privileged context. And that is an important thing to note, because when Docker is ran with the privileged flag, it'll share devices, like character devices and stuff, with the host, between the host and the container guest. Because Docker, sorry, were you going to?
I was just going to add on that, like, running it as privileged basically means if you get root inside of the container, you can get root in the host. Like, that's the deal with privileged. If privilege basically means a root is root equivalent.
Yeah. So basically, for those who don't know, Docker isn't a full VM, right? It's not gonna be running its own guest kernel. It's gonna be sharing the kernel with the host. And that's kind of where the problem comes into play. The problem is that the device sharing is overly permissive. The persistent memory, or PMEM device, is exposed to the sandbox with read-write capabilities, and those devices can be used to get control of the host file system and change file contents using the zap block command in ext4, I believe they said the file system was. Initially, they tried using that to get control over etc password, which didn't work at first because of how Linux kernel does file caching. Basically, it won't propagate file changes until the cached pages are discarded. I think we talked about this before in the context of another vulnerability, but that's where the royal flush of the name comes into play. They basically use the fadvise POSIX function to tell the kernel to flush pages from the read cache to get the changes propagated to take control of etc password. To be clear, that's not the only attack you could do. You could essentially attack any file on the host file system, as I understand it, so your possibilities are basically endless there. MSRC stated that this issue had no impact on Azure Functions users, since this was these Docker containers run inside of a Hyper-V guest. So I was kind of saying earlier, Docker doesn't do its own isolation with running its own guest kernel. So what Microsoft does is they run the Docker instance inside of a Hyper-V guest. So they have that multi-layer isolation. So even if you pulled off this attack, you wouldn't be able to take control over the real host, since the host you compromised in this case was still a guest, right? It's kind of like nesting dolls with sandboxing. Still interesting though, and this would definitely be part of a chain if you were trying to do like a full escape. So yeah, cool attack. But it's mainly just comes down to don't be oversharing when it comes to sandboxing. The entire idea of sandboxing is you only provide what's absolutely necessary, right? And from what I could tell, these PMEM devices definitely were not necessary and should not have been exposed to the sandbox with read-write capability. So
Yeah, although like the fact that it's exposed with read-write is intentional, because the default I believe they show is that everybody does not get read-write access to it. They show a screenshot showing exactly that. So the fact that they do enable read-write access within the Azure Functions container, it makes it seem like there is some reason they did that. It's not clear what that is, but somebody made that decision at some point.
yeah, and it seems like this issue is probably still an issue because they never mentioned that Microsoft fixed it, and like I said, they mentioned that MSRC didn't consider it a security impact. Because I guess where it's running inside a Hyper-V guest, they don't consider that a security barrier, being able to go from Docker container to escape outside the Docker container. It's another one of those cases where I don't necessarily agree with Microsoft and how they set security boundaries, but I mean that they are the vendor.
It's something Microsoft does, though.
Exactly.
This is classic Microsoft.
Par for the course.
Do some security, implement some security mechanism, but say it's not a security boundary.
Yeah, won't fix. favorite tag of Microsoft when it comes to those types of security issues where they don't consider it a security boundary, which I think they should, but whatever. We have a quick issue in QNAP NAS in the surveillance station local display function endpoint. It takes untrusted data in the form of parameters in an HTTP request. It's basically one of those don't use stir copy where you shouldn't type of issues where they use stir copy when receiving SIDs and parameters. It has a fixed size buffer. I'm not exactly sure of the length because the snippet from the IDA decompilation was pretty limited. But just by passing a really large string that's like hex 5,000 bytes long, you can stack smash, right? You can just overflow the stack buffer. Assumingly, they don't use stack cookies because this issue was labeled as a pre-auth remote code execution, which isn't too surprising because, as we've said before, unfortunately, mitigations are basically non-existent in these types of products, especially stack cookies. Because if they had stack cookies here, this probably wouldn't be exploitable for getting code execution, because basically what they're doing is they're just smashing the stack to get to the return pointer, and there's nothing protecting that return pointer.
But it would have so much worse performance if they had stack cookies.
I know, you would run like maybe 2% performance overhead.
I don't actually know what the performance overhead is for stack cookies, actually. It is a lot higher than some of the other things like DEP or ASLR, which... Well, DEP at least hardware enforced, because it is a software thing. Like, it does the extra push every time, it does the extra check every time you return. So if you've got a lot of functionals, like, there is a significant overhead. That's why there's usually some heuristics on how the compiler decides to include it or not. Well, you can change that to include it on everything, but by default, most will use a few heuristics on it. But yeah, I mean, that would prevent
anywhere that takes untrusted input should have a stack cookie in it.
Yeah.
Yeah. So, yeah, pretty straightforward issue. Just, like, it's not that you can't use stir copy anywhere, but if you're going to use stir copy, make sure it's taking a string that is entirely validated, and it's not going to be just some really long string that somebody passes in or something, so...
Yeah, I mean, if you use stir copy and you go and put a null byte in manually, like you just jump ahead like 0x80 bytes, toss a null byte there, and then stir copy, you're kind of limiting it that way. I would rather see, stir end copy or something, where it's kind of built into the function, but there are secure ways of using stir copy.
Yeah. Our next attack is on Greyware's Domain Time 2, which is a software and custom protocol for trying to keep clients and servers as closely synchronized as possible. It's a man-on-the-side attack, which, I'll be honest, was a new term to me. It's basically like an MITM, except you can't manipulate the data in flight. though you can inject data in between. So it's kind of like an MITM, but a little bit more limited. So one of the things the application will do, which is pretty common, is it will check for any updates from the update server when it launches, which it'll do by sending a UDP query sent from the DT tray application. If an attacker can intercept that and respond with a legitimate looking URL before the actual server does, they could be fooled into downloading a malicious binary, right? So it's basically just like a race on the communications between the client and the server and being able to inject that response. It is worth noting this isn't the privilege escalation. It basically gets an attacker a foothold onto the system, but you're going to be compromising the application at the level it's running at, right? You're not going to be able to escalate using this bug, which they point out in the blog post.
Like, a remote user shouldn't have code execution on your system at any user level. So it is kind of a escalation of privilege in that sense, but it's not an elevation to like root, or I guess in this case, the system or admin.
Yeah.
But I will also mention, they do talk a little bit also about the other option of racing the DNS. So DNS also potentially happening over UDP. So you can inject your own response to the DNS request. So then you could use the real address or a real looking address, just putting in HTTP instead of HTTPS, and intercept that also, because you control where it's going to go by intercepting, or by manipulating the DNS response, I should say. So that's kind of the other attack scenario. Besides just racing this one, you can also just race the DNS lookup, which is one of the options they provide in their actual attack script. But overall, I mean, it's a simple issue. Just really stems down to the fact that UDP doesn't really have any guarantees and can easily be spoofed.
Yeah, it's interesting. This isn't a product that, like, I don't think we've ever really covered before, like this type of product with time synchronization. So it's always nice.
I think we covered. I feel like we've covered one time server issue before. I couldn't tell you what episode though.
Okay, that would be interesting to look back on, because I thought that was one we hadn't really covered before in terms of product type. But yeah, anyway, let's move into the most fun exploit section of the show for me, which is the kernel exploitation stuff. Our first kernel exploit is from Alexander Popov, coming out of ZeroCon. It is a 4-byte write after free in the Linux kernel in the newer AFVsock socket family. Specifically through a socket option, because of course. It boils down to a race condition where the virtual socket transport is copied outside of the locking window. So it's kind of that classic not maintaining ownership of a pointer before copying it, right? Pretty blatant race. Whenever you're copying a reference to something, do it inside of a lock, or else it's going to be raced, or it's going to have the possibility of being raced. Funnily enough, this bug was found by syscaller, though it was really difficult to reproduce because the bug triggered when updating a buffer size. So they had this socket option for being able to change the buffer size, which is pretty common in the networking stack. But the path that had the UAF would only get taken if the size was different. Otherwise, it would just bail out early. So Alexander states they weren't totally sure on how syscaller even managed to hit this crash, because it took size from the return value of the clock get time syscall, which normally would be consistent because like the input is generated it's generated at time of fuzzing, not at time of execution, like when it's generating the inputs. I can try to shed a bit of light on this. It basically comes down to how syscaller runs programs. So the syscaller devs have done a few cool talks about how their fuzzer works, but basically they take these programs, which are defined manually, and create sets of them. And mutating them involves like adding in calls or removing them or change data passed to them. And one of the things it tries to do is it can try to force races by sending a program to a blocking program to basically force another thread to run when it reaches that. Which normally, like, blocking programs are used to prevent infinite hanging on reads and writes, for example. So if you try to read when there's no data there, it's going to hang infinitely. So syscaller will set that as a blocking syscall, which they abuse for races, right? My best guess is something in the routine that uses the race mode allows the parameter to be regenerated for that thread. That is just kind of speculation on my part. It is kind of difficult digging through this syscaller code base, honestly. It's kind of a pet peeve of mine. I do not really like the way the code is structured, but yeah, it is a little bit strange. I don't know for sure, but I'm guessing something with how the blocking, like the race mode works, where they try to get around blocking programs, leads to the parameter being regenerated there. Anyway, this leads to a 4-byte write after free, 40 bytes into an object in the kmalloc 64 cache, which for those who don't know, Linux kernel has various kmalloc anonymous caches. So when you have like a use after freeze, for example, you can only hit objects that are in the same cache size. So for kmalloc 64, that would be any object that's 33 bytes long to 64 bytes long. So yeah, he used this to smash an overlapped message object, which gets allocated in the message send syscall. Ironically, he smashed the security pointer inside that object, which is used for SE Linux stuff. That pointer basically gets freed whenever a message is received and popped out of the queue. So he was basically able to turn that 4-byte write after free into an arbitrary free, which, when chained with an info leak, that'll get you code execution with enough work, because you can get a targeted use after free on whatever pointer you want to target, which he did do. The info leak was pretty noisy, mind you. He basically abuses a warning through a caught null dereference on the transport with a similar issue, which is viable. You do get kernel addresses from the register context dump, but it's very noisy. It's directly inside of the log. So it's totally fair for exploitation if you don't care about that, but there are some situations where you don't want that information going directly into the log, because that leaves a trace, basically. He then uses arbitrary free to get a full use after free on the same object, that message object. So it's the same object, but being able to control the whole object instead of just 4 bytes. He uses that to get arbitrary read by corrupting the message data information. He then finally uses the UAF again on a different object, the SKB shared info object, to get code execution through the destructor on that, which he uses to construct arbitrary write. So ultimately, when you have arbitrary read-write, getting root is pretty straightforward on Linux. You just have to smash the credentials of your process. Pretty straightforward to do, unless you're looking at Android and you're on like a Samsung phone or something and you have Knox to deal with. But this is just hitting Linux in general. It's not Android specific. In fact, this socket probably doesn't even exist on Android. One thing I thought was cool was at the end, he points out what would mess up the exploitability of the strategy. So he points out a few things, like noting that something like CFI would stop it, obviously, where you're using the destructor indirect call to get code execution to get the arbitrary write gadget. Also noting that preventing user fault FD would make it harder to exploit the UAF, which, for those who aren't familiar with like Linux kernel exploitation, user fault FD is a pretty common trick. It basically allows you to handle page faults in user space. So you can set a handler that hangs the kernel when it goes to read that address to like freeze a thread, essentially, to keep your allocation in place. So preventing that would probably hit the stability, though I don't think it would prevent the exploit entirely. Another thing is the demessage restrict kernel option. If that was set, it would prevent the info leak because the register context wouldn't get dumped to the message log, right? It might be possible to derive a different info leak from this issue. That said, it might be difficult. You would basically have to hunt for a different spray object to target where you are fixed, where in the object you're hitting. Like, you're always going to hit 40 bytes into the object. That is going to be really tricky to find another object. But it is technically a possibility that you could use to derive an info leak if you really wanted to.
Yeah, it would be tricky, but given... like, I feel like kmalloc 64 should have a good number of objects going through it. Like, that's not a crazy size. Like, it would take time to find something, or maybe, code heal query. But otherwise, like, I think it's reasonable to assume that there might be another object.
Yeah, the kmalloc64 cache is one of the most commonly used caches. It's one of the most popular ones. So yeah, I mean, there's probably a different exploit strategy out there, but you have to put a lot of time into finding it. This is actually an area where something like CodeQL would probably be a good idea to use. Try to query for target objects you could hit. If you're looking for like an exercise or something to do in CodeQL, that could actually be a very good application for that. But yeah, very cool exploit. Another thing I want to call out is the fact that this explicitly bypasses supervisor mode access prevention and supervisor mode execution prevention, which, like, these are pretty powerful mitigations that are often hand waved from a lot of the kernel exploit write-ups I've seen. So it's nice to see that it's mentioned here and isn't an issue. It's not directly bypassed, but it just goes to show that these mitigations aren't going to stop everything, right? And for those who don't know what SMAP and SMAP do, they basically make it so the kernel cannot access or execute anything in user space when running in kernel mode, right? So you can't fake objects in user space or use ROP chain gadgets that are in user space in a kernel ROP chain. That's basically what those mitigations are doing. In this case, though, because he has the info leak and he's able to set up the arbitrary read and arbitrary write gadgets, that's basically not an issue. So yeah, very cool post, and it's always fun to see kernel stuff. And we have more kernel stuff coming up too. The Flow also put out a post about exploiting two bugs we previously covered all the way back on episode 49 of the podcast. It's a stack-based info leak in the A2MP protocol where there were uninitialized fields in a structure leaked to user space, and there was a type confusion on the mode set in the A2MP channels where the receive function will call the skFilter function on channel data, thinking it's a socket object when it's actually an AMP manager object. So I'm not going to go too deep into the exploit or the vulnerability details because we already covered those, like I said, back on episode 49. So this write-up doesn't really talk about the vulnerabilities much either, beyond what they are. It doesn't go into in-depth detail. It mostly talks about the exploit process. So Z, I know you were looking at the exploit strategies and probably have a better grasp on them than I have because I was kind of more focused on the other issue. So I'll let you take this one away.
Yeah, fair enough. And this one is a little bit complicated in how he actually goes about doing the exploitation. So hopefully I don't butcher it. That said, if I do and you have no idea what I'm talking about at some point, it is a really good write-off. Like, gives a lot of information that I'll try and summarize here. But as Spectre already mentioned, there were the three issues. We've already talked about them. The two that actually matter here is just bad choice, which is a stack-based info leak. Fairly straightforward. Basically, in the response object, it creates in response to one of the A2MP protocol requests. It has this response object, RSP object, fills out the ID and status of that in their case, and sends it back to the user using like size of. So all of the things that are uninitialized in that get leaked out. That's all that really matters, is that you're getting some stack information out of it. Bad karma, Ms. Spectre also said, is where when you have an A2MP, or when you have that sort of channel, it uses the enhanced retransmission mode. And that's by spec, I believe. It'll use that, and sorry, I guess I am getting ahead of myself. With the A2MP channels, it's expecting a socket, but it gets an AMP manager. So in order to actually start exploiting this, though, the issue I was just starting to mention with the mode is that you can't actually access any of the A2MP code, or at least stuff you need, while the channel is configured in that enhanced retransmission mode. What happens there is skFilter will end up crashing when you try and actually access the A2MP subroutines. So the first thing that he kind of has to figure out is, well, how do we change that mode? In theory, shouldn't really be able to. But he does find that you can just send the reconfiguration thing, even if it hasn't been requested. Like, even if the client side hasn't requested some to reconfigure, it can just say, hey, yeah, reconfigure to mode basic, send that off. And basic mode, which you shouldn't be able to use for this type of channel, effectively just uses the ops pointer and uses that as for all the function calls. So that gives you kind of a target for the EIP or for RIP control. So you've got you've got that as a way of kind of getting around and getting access back to all of the A2MP. So now focusing on kind of the real issue. And I'd encourage you just to read the write-up for that little bit. I feel like the actual type confusion, I think, is a bit more interesting. And that's in a couple ways. So as we've already mentioned, you've got this AMP manager and the socket class. So that's where your confusion's happening. The AMP manager is 0x70 bytes in size, but the only access on the actual socket that's useful is this RCU dereference. Obviously, if you're listening, you can't hear this, but filter equals RCU dereference, and it goes to the socket filter. That happens to be at offset 0x110. So it's actually beyond the end of the AMP manager object itself. So even if you had complete control over that AMP manager, you would actually be going beyond the edge of the actual object. So what they had to do, instead of using the AMP manager for very much, instead what happened is they used some heap grooming so they could get something they controlled immediately after where the AMP manager gets allocated. So effectively needing some primitive that can allocate, 65 to 128 bytes. So basically landing it in that kmalloc 128 and not in like 64 or anything lower, nothing higher. It goes from kind of finding the get AMP associative response. I have no idea what that does. But what it does allow is it'll duplicate a string in memory. Just try to find the code here. It'll use kmem dup on it or duplicate it. So that basically becomes the primitive that gets used here for any of the heap allocations. You're able to control the size that gets copied and the actual data that gets copied into it. The only thing is you can't control the free. And if you're wanting to use this for like heap grooming, you're going to want to have some control over that free to kind of create holes where you want. Interestingly, this thing kind of leaks memory because it will close this ASOC value. Or sorry, it'll free that when the channel closes. But every time you call this thing, every time it looks it up, it just overwrites that pointer. So in theory, you call it twice, and what you end up having is it'll overwrite that pointer, so when it frees it, it only frees one of them. So by calling this thing twice and then closing, and doing that like a bunch of times, you're able to heap spray, and you're able to heap spray a pattern of allocated free, allocated free, allocated free. Which is exactly what you need for abusing the bad karma, where it's going to try and access beyond the edge of the actual pointer you provide it, or at least beyond where it should be. So with that, they're able to get control of the memory that is one block away from that AMP manager. So you're able to get control of the sk_filter. This is a long post. I can't find the code to pull it off. But you're able to get control of that dereference at that point. You control what's there, and that's where leaking the memory, you need to know some pointers. I'm going to say kind of lucky, kind of control, was able to leak using the bad choice, was able to actually leak the pointer to the channel object itself. And was able, that basically ends up being in kmalloc 1024. And I'm just going to say, in chat, we've had a few people asking about PS4 exploits. We have no update on that, and asking isn't going to help. So coming back onto the topic here, With bad choice, you're able to leak memory. I won't go into all the details, but effectively by making one call and then the next call, he was able to control the stack, so it exposed the value that was useful, specifically the L2 cap channel object. So putting kind of everything together now that I've talked about, you're able to control that dereference. And the dereference itself actually gets a little bit more complicated. Let me see if I can find the right code for it.
Is it because of the RCU aspect? Or is it just the way that the pointer is used?
The reason why it gets a little bit more complicated is just because you've got several dereferences. I just found it here. The SK filter, you control that dereference, so you then need to control how it does the probe dereference, and then finally the actual function call dereference, or like the function pointer dereference. So it's just a little bit more complicated because you've got the 3 layers of indirection.
So you can fake the filter pointer and then you set up a fake object to get the function pointer hijacked. Yeah, okay, that makes sense.
Yeah, and it helps because he has that kmalloc 1024 block that he can control. And that's from bad choice. Either way, so you are able to control that. Use that RIP control to get to a stack pivot that points that 1024 size buffer. And then it was just a ROP to calling run command, which was pretty much the same technique we saw in... he has a link to it. We've talked about it. CV 2019-18683, which was a post actually from Alexander Popov, which I believe we would have covered early last year. But yes, that leads to the ROP in a very, and we covered it in episode 25. Or we covered that technique, I guess, in episode 25. Very kind of roundabout. It's a detailed blog post. I am definitely not doing it justice and trying to explain everything here briefly, or not so briefly.
One thing I am just trying to check really quickly is, do you know if the fake object, like the fake filter, is kept in user space, or does he spray it into kernel space?
It's kernel space. That's where the heap primitive that I mentioned.
Right.
Spraying with that.
I just wanted to be sure. I felt that was the case, but I wanted to verify that. The reason I bring that up is because, like I mentioned with the last issue, if this were faked in user space, which technically you could do, you would have an issue with supervisor mode access prevention. So with the way that he does it here, with spraying it into the kernel, again, it's getting around those mitigations of SMAP and SMAP. So yeah, that's cool to see that we have back-to-back posts that both handle that mitigation then. So.
Oh, I guess one other thing I'll call out. Actually, I guess it doesn't really matter. But now that I've teased it, we did have to use a fragmented packet at one point just due to the MTU size. But you can get more details by actually reading, I guess.
Yeah, like you said, it's a very long post. There's a lot of good information in there. It's hard to cover on the podcast because we'd be here for hours.
Yeah, it's a good post. Like I would absolutely recommend giving this a read. He covers a lot of the details that are interesting, and there's not a lot of fluff.
And it's a good insight into what's involved in modern kernel exploitation. You kind of get that question quite a bit with like, okay, what does modern kernel exploitation look like? Because a lot of the resources out there are for older exploits from like 2014 or 2016 or whatever. And the landscape has definitely changed since then. So these types of write-ups are kind of a bit rare, but they give needed insight into what's involved in modern kernel exploitation. So if you're looking to get into that kind of stuff, this is like the post that you should read for sure. And the flow is a really good writer. So like Z said, not a lot of fluff or anything there. It's all relevant and good information. So we'll move on to our last exploit topic. We'll end it off with a new CFG bypass technique in Windows using remote procedure calling, or RPC, that was discovered when analyzing an Internet Explorer vulnerability. The post goes into some details on the vulnerability, which is a use after free in JavaScript attribute objects where the value of callback can get abused by an attacker to clear the attributes, which isn't accounted for when the callback returns. Now, what CFG does is it tries to make it so that you can't hijack indirect calls as an attacker from something like a vtable to get code execution, even if you have a use after free. And the way it does that is it stores a bitmap of functions which are valid to be jumped to, and it does like call target validation to ensure, okay, where you're trying to go, is that actually somewhere we've marked as safe to jump to? If not, crash or whatever, right? Or just don't do it. I think crash is the common side effect there. But yeah, it's basically in place to prevent hijacking of the control flow, as the name implies, right? Control flow guard. What they managed to do, though, was abuse the Windows RPC to get a call gadget that allows them to call any function with any parameters as long as the function is in that valid bitmap. Then by using that, you can call virtual protect, which is in the bitmap, and then modify the guard check memory function pointer to be read write execute. And then you can remove the pointer which tries to validate the call target and just replace it with a syscall ret, which is basically just patching out the call target validation. You can then pop off the write flag again, doing the same trick, and CFG is no longer an issue. You basically just knock it out. So yeah,
and I love when you deal with mitigations by just turning them off on the fly.
Yeah, yeah, it's pretty funny. All that work and it's just turned off like an on-off switch. But yeah, basically just abusing the fact that you can use RPC to call valid functions, but abusing them in a way that Microsoft didn't really expect, right? Calling virtual protect in order to patch the memory and remove their mitigation. And this is one of the things where like software mitigations are kind of weaker. If this was a hardware mitigation, this wouldn't fly. But because CFG is software, that's where it's kind of weak to these kinds of attacks, right? So it's a cool post.
I will mention 0xabc0 mentions that this is not new. Fair. I mean, I was kind of reading this, feeling like I'm surprised we haven't seen this before. Nonetheless, I mean, it's a good write-up of a CFG technique, but yeah, it does look like it's not new. There is Pwn2own, I'm not sure how to say that, has a mitigation post here. I'll actually include that here in the description. But yeah, so it looks like it is a known technique. Nonetheless, it's still an interesting write-up that's come up. I guess it's not from the last week, so maybe we'll just have to cut this section instead.
I mean, I still think it's cool to bring up, and I was kind of thinking the same thing when I was reading it, was that not to downplay the issue, but this is like something where it almost seems too simple of a technique for it to not have been known by other people, as far as like that kind of technique goes. So
no, I mean, when it comes down to it, like the control flow guard in this case, software based, very very wide. Like, it just allows you to call any function as long as it's a valid function. You can call it. Like, that's the only criteria. It doesn't do any sort of checking to make sure like this area of code should be able to call that function or needs to call that function. And so because of that, like, there are definitely a lot of techniques of getting around CFG. It's a good clear write-up though, nonetheless.
Yeah.
And I mean, I wasn't familiar with this myself, though I also don't do much on the Windows side.
Yeah. Basically what I'd say there, like, what you said kind of sparked something in me. It's one of those things where coarse-grained checking is just always going to kind of let you down, right? If you had that fine-grained checking, not just having a bitmap of what's valid, but having bitmaps specific to each area of what's valid for that area, that would have protected against this type of attack. But where it's so coarse-grained and it's just one big bitmap of what you're allowed to do, yeah, there's a lot of different potential little tricks you can use to get around it. So, yeah, and that's just one of them. All right, so we'll move into our last topic of the show, which is a research topic. It's basically security things. It's another Keys Cook post on Linux 5.9 this time. A few things to note we can talk about, one of which killing out an entire class of vulnerabilities. So one of the things introduced was Clang's automatic zero initialization of all stack variables. So yeah, rest in peace, stack-based info leaks like the ones we've covered in this show. Like the flows issue where there was a struct that was leaked on the stack, and you use that to chain with your exploit. That would not fly with this mitigation, because all of those fields would be initialized to 0. There wouldn't be any uninitialized kernel memory to leak. So yeah,
Although
that
we
would
have to
kill
see
an
it
entire class
actually
of attacks.
have to see it actually getting used too.
Yeah, that is a fair thing, that some of the things in these security posts are not on by default. You kind of have to turn them on, which most people don't do.
Yeah,
because
but still interesting to kind of talk about what's coming down the pipeline.
For sure. The other thing that was interesting here too was the hardening of the free list on the slab allocators against double freeze and cross cache freeing. So Slub has had this for a while. It's not on by default, but Slab hasn't had that option. So while the Slab allocator isn't used as much, it's still a good step to be able to have it if people want to turn that on. Usually you'd only, like, this is another one of those options where it's not on by default. It's just kind of there if you want to have a hardened build, I guess, which some people do absolutely do, but a lot of people don't go through the process of changing configuration options when building the Linux kernel, because there's so many of them, and you have to kind of know they exist. You're not just going to stumble upon it looking through kconfig and go, oh, hey, this one out of the 300,000 things that are here is here. That's cool.
You mean you don't read through the dialogue when you set up a new config, or even just do old config and like go through absolutely every option?
No. Yeah, defaults are fun, but yeah, I mean, it's good that it's there, that the option is there. I think the most notable thing here is that 0 initializing thing with Clang. I think this is a little bit different than another mitigation I was kind of criticizing with Z. We don't have a topic around it on the podcast, but there is another thing that Clang has recently introduced in Clang 11, I think, where they added being able to 0 register values after a function is finished, like before it returns, and your performance on a kernel that is built against that would tank. It would be terrible. I think this is different. I think this is basically, it's just initializing stack variables. It's not initializing all the registers. So yeah, it's going to be an effective mitigation because there's a lot of stack-based info leaks out there in the kernel. So it's a class of attacks that makes sense to kill from a developer standpoint. There is some other stuff in here as well, such as like a new capability, some stack protector support for RISC-V, which, I mean, RISC-V, who's using that? But, I mean, yeah, the most notable ones are the cross-cache freeing, double free protection on Slab, and the 0 initialize. So, yeah, just like you said, one of those things to look out for coming down the pipeline. That said, that'll conclude our topics for this stream. I think somebody in chat just actually, they posted the commit that added what I was talking about. So maybe we can bring it up on stream quickly since we have that. But yeah, they basically added it so it puts in instructions to 0 out all the registers. Like, this would absolutely mess with like instruction caching, and it wouldn't even really be that effective because it might kill some ROP situations. It won't kill all of them, and it won't kill job. So you're losing a lot of performance for not a lot of gain, really. But yeah, it's kind of funny to see. I don't know why Clang decided to invest time into that. Oh, actually, this is GCC, sorry. So does GCC do the same thing as well, zeroing out the scratch registers? Okay. I don't know.
They
I don't know
both do
why.
it, but Clang did add it, as you said, with Clang 11.
Dude, I don't know why. Like, this is kind of a waste of time in my opinion, but hey, it gives a good laugh. But anyway, that'll wrap up our topics for the show. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube, as well as Anchor.
Sorry to just kind of jump in on you. I guess reading the tweet from Keys Cook, he actually mentions that GCC just mentioned it in GCC 11. So if it's in Clang, I'm not sure what version. I'm maybe mistaken about saying 11.
I might have gotten them confused too. I thought it was Clang, but it might have been GCC. Okay, fair enough. Yeah, my bad then. Anyway, yeah, thanks to everyone who tuned in. You can catch them on Twitch or on YouTube as well as Anchor. We're on pretty much any platform that's common for podcasts. Follow us on Twitter and join our Discord for notifications and join the community. I do apologize for the lack of streams over the last couple weeks, or over the last week or two. Yeah, I haven't been able to do the PS4 streams just because I've been very busy with other work. I am going to try to get back to doing those streams this week. So just check out the Discord and see on Twitter. We'll post whenever I go live. But yeah, I do apologize for the lack of those streams. But we will hopefully be resuming them soon. But yeah, with that said, we'll be back again next week with the podcast at 3 p.m. Eastern, 12 p.m. Pacific, and we will see you all then.